Welcome to variance and standard deviation. So with variance and standard deviation, they are both the measures of spread. How far the data is spread from the mean. So we're going to focus on variance first, and we're going to look at two formulas, both given on the formula sheet. So the first formula, we find the difference between each value and the mean. We call this the deviation. So our x is our value and our mu is our mean. So we do x minus mu. The second step is to square the deviation. So whatever answer you got for each of the individual ones in step 1, you square them. And then step 3 is you calculate the expected mean. So we looked at this in the last video. That's the weighted mean of the squared deviations. So we do the sum of the squares that we did in step 2 times the probabilities. Let's have a look at an example. So let's say we had scores of 0, 1, 2 and 3, and their probabilities. Probability of getting a 0 is 0.1, probability of getting a 1 is 0.15, probability of getting a 2 is 0.4, and the probability of getting a 3 is 0.35. A reminder, our probabilities have to add up to 1. So then when we do x times px, so our score times its probability, we get 0, 0.15, 0.8 and 1.05, giving us a mean of 2. And we did that in the last video when we looked at our expected value. So the expected value, or the mean, is equal to 2. Now we do the squares. So we take, let's say, the first column. So we take the x value of 0 times minus the mean, which was 2. So 0 minus 2 is minus 2, and we square that, and we get 4. The next one, the x value is 1. We minus the mean of 2, which gives us minus 1, and when you square that, you get 1. Third column, score of 2 minus 2 is 0. When you square that, you get 0. And finally, 3 minus 2 is 1, and when you square that, you get 1. So for our final step in this formula, and this is where we find our variance, you take the answers that you just got from the row above, the squares, and you times it by the probabilities. So the first column, the 4, is times by its probability of 0.1 to get you 0.4. The next one, 1 times its probability of 0.15 gets you 0.15. Third column, its x minus mu squared is 0 times 0.4 is 0. And finally, 1 times 0.35 is 0.35. Remember, the formula says the sum of that row, so I add 0.4, 0.15, 0 and 0.35 and I get 0.9. That's my variance. So for the second formula, the variance can also be calculated by doing the sum of the x squared px. So the x squared, the score squared, times its probability, minus the mean that we calculate squared. So let's have a look at this using our same data from before. So instead now, under the xpx row, where the mean was 2, we're now going to do x squared px. So the x squared is we square the score and then we times by the probability. So the first one, 0 is the score, we square that, we get 0 times the probability of 0.1 is 0. Second one, score is 1, square that is 1 times the probability of 0.15, gets you 0.15. The third column, the score is 2, square that is 4, times that by the probability of 0.4 and you get 1.6. And the final one, the score is 3, you square that is 9, times that by the 0.35 and you get 3.15. Add that across, so the sum of the x squared px is 4.9. Minus the mean, which is 2 squared. So 4.9 minus 4 gives us 0.9. Exact same answer we got before. So we're not changing, we're changing our answers. We're just showing you that there's two ways to get the variance. Final step is standard deviation. Now standard deviation is very simple. It's represented by the symbol sigma, and all it is the square root of the variance. So for the last two examples, the variance was 0.9. The square root of 0.9 is 0.95. That's the standard deviation. for a population data, so where we have taken all the everything into consideration. So note that the standard deviation is a measure of spread. If you were to double all the values, then we would actually double the spread, and we would hence double the standard deviation. And if you multiply all the values by k, then the standard deviation would also be multiplied by k. Thank you.